Okay, so now for this, all right, here's some properties of isosceles triangles, and I know you guys know what isosceles triangles because we learned them in 6th grade. All right, sometimes even in 5th grade. All right, so when you have an isosceles triangle, two sides are the same, and technically the formal definition is at least two sides. So if you have an equilateral triangle is also called isosceles, but we never really say that. All right, so when you have an isosceles triangle, the two equal sides are called the legs. All right, and the third side is called the base. All right, and we say that if two sides of a triangle are congruent, then the base angles are congruent. So we would say angle 2 is congruent to angle 3 here. Everybody happy with that? All right, and the two sides that are congruent are called the legs, and the third side is considered the base. All right, so that is an actual theorem that is very easy to prove. In an isosceles triangle, if two sides of a triangle are congruent, then the angles opposite those sides are congruent, or the base angles are congruent. All right, that is a theorem. Also, if two angles of a triangle are congruent, the converse is also true. All right, if two angles are congruent, then the legs are congruent, or the opposite sides are congruent, however you would like to say that. All right, if I'm writing this in a proof, I just say if the base angles are equal, then the opposite sides are equal. All right, if you want to put the isosceles triangle theorems, I'm totally fine with that. All right, anybody have any questions with that? All right, super easy. And again, this is also easy to prove. The properties of equilateral triangles, right? If you have an equilateral triangle, that means all sides are equal. If all sides are equal, then all of the what? Angles are equal. And we actually know those angle measures. Those angle measures are going to be 60 degrees because 180 divided by 3 is 60. That's pretty easy. I don't think anybody in here that's new information to. All right. Anybody have any questions with that? Anybody have any questions? All right. So let's see what's going on here. All right, just to be sure, I even thought about just skipping all this because I wanted to get right to the proofs, but I thought I better not. If AB is congruent to CB, then the two congruent angles are what? If AB is congruent to CB, come on, guys, we got to participate if we're going to get done. Go. Yes, BAC and BCA. Thank you very much for that help. Now, if EAC is congruent to ECA, then the two congruent segments are, thank you, AE and EC. Those are the congruent sides. Anybody have any questions? Okay, what is FH? I need the length of FH. Wow. Come on, Aiden, let's just you and I talk. What is FH?
120.
No. What are you talking about, 120?
12.
12, of course. Right? How do we know it's 12? First off, this is 60 and this is 60, which forces this to be 60, which means it's actually an equilateral triangle. So if it's an equilateral triangle, all the sides are the same. However, we really didn't need to know that because 60 and 60 are equal. The opposite sides are equal. So you understand what I'm saying? Don't just look at the right and left sides. All right, it doesn't have to be the right side and the left side. All right, so let's make sure we're good over here. Well, all those angles are what? 60. All right, so MRP would be this guy right here, 60 degrees. Not a big deal. All right, so number 5. How am I solving for Z? Go ahead, Tanner.
2Z minus 15 is equal to 9.
Yes, of course. opposite sides are equal. Opposite sides are equal. So obviously then Z is equal to what? 12. Z is equal to 12. Anybody have any issues with that so far? All right, over here. Help me with number 6. Yes, 4x minus 2 equals 62. Thank you very much. So from there, we can just say 4x is equal to 64. So x is equal to what? 16. I'm pretty happy with that. Everybody good? Anybody have any issues? All right, now we get to the proofs. All right, here we go. Let's see if we can do this now. So ABC is isosceles. And because it's isosceles, they're going to have to tell you what two sides are congruent. So they told you that AB was congruent to BC. Does everybody agree with that? Now, EB bisects what? So everybody in here, take the time now. EB bisects ABC. I want everybody right now to mark the figure. If EB bisects ABC, everybody should be able to tell me what's true. Tell me, Sebastian. Say it again. Yes, thank you, sir. That means these two angles are equal. All right. So here we go. Let's go ahead and write out the given or copy it like I'm copying it. I think is perfectly fine. Step 1. All right. Now there's not really anything difficult, but you know, we have to show 3 parts are congruent. All right, so somebody step up and tell me the first part. Colson, what's true? Step number 2, come on. I'm asking everybody to participate today. Tell me what you're thinking.
EB bisects
Uh,
ABC.
So what's true because of that?
That angle ABE is congruent to BBC.
That's what you're supposed to say, buddy. Angle ABE is congruent to angle EBC. What's the reason?
Definition of us.
That's right. That's right. Definition of bisect. That's what that means. All right. Definition of bisect. All right. So now we have the angle marked. All right. So now why was I able to mark AB congruent to BC? Or how do we know that was true? Tanner.
Because it bisects it. So
No. Nothing to do with bisect. Why is AB congruent to BC? Tell him. Yeah, definition of isosceles. All right. Now, does everybody understand? We wouldn't know what side is congruent unless they tell us, right? But AB is definitely congruent to BC, and I would say that's the definition of isos. Definition of isosceles triangle. All right, so now we're missing one more part. Come on. Come on. Kyla, what? Yes, we're exactly right. Come on, BE is congruent to BE. And of course, that would be reflexive. And so now we can just state what?
Triangle ABE, congruent to CBE.
We could probably, but it's better we can just say what's true about the two triangles now. I know it's been a long weekend. Why?
Because of side angle side.
Yeah, side angle side, guys. Those triangles are congruent by side angle side. Everybody back in the game? I know it's been a couple days. All right, anybody have any questions with that? Now, let's say there was something else. Why is angle A congruent to angle C? Well, you could say that. You could definitely say CPCTC, but sometimes you're going to need those angles congruent. How do I know they're congruent without doing CPCTC? Because it's an isosceles triangle, right? So if, and again, if I had to say that, I would just simply say base angles of an isosceles triangle are congruent. Is everybody with me on that? Because if you say that, that's coming from a theorem. Does everybody agree with me? So you could just say isosceles triangle theorem. But I always just say base angles of an isosceles triangle are congruent. Everybody's good? All right, let's knock out the next little bit. Let's see what's next. Oh yeah, these are kind of good actually. All right, please pay attention, you guys. Come on, I want to get the work done. All right, so stay with me. AB is congruent to AE. So AB is congruent to AE. I need someone to tell me.
Angle ABC,
Yeah.
angle AEB.
Yes, that is true. If you don't hear him, you know, that's why I'm asking everybody to speak up. All right, this angle right here is congruent to this angle right here. Thank you very much. Okay, someone else get involved. If you haven't said something, I want someone else to say something. If angle ABF is congruent to AFB, name two congruent segments. Tell me. AB and AF are congruent. All right, come on now. Someone else who hasn't said anything today. If CA, find CA, is congruent to DA. Come on, Liam. If CA is congruent to DA, what angles are congruent?
ACD and ATC.
Yes, very good. All right, court, number 12. If angle DAE is congruent to DEA, what two sides? Yes, I told you this is easy. All right, does anybody have any issues with that? Anybody? AD and what? DAE is this angle right here, correct?
Yeah.
And DEA is this angle right here, right?
Yeah.
So he said AD and ED.
Yeah.
What did you say?
Would it be AE?
No, 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 no.
Why?
Because these are the base angles. The base angles opposite sides are equal.
Oh.
You with me now? All right, everybody do 13 and 14 on your own. All right, hopefully you did them already. If I'm looking at 15, these are kind of like the SAT problems. That's kind of why I like doing them. All right, what is the measure of angle BAC? What are we thinking? Why? Yes. All right, which means those two angles have to add up to what? These two angles have to add up to what?
120.
That's correct. And 120 divided by 2 is 60 because they are equal. All right, Mr. Lockman, you're up, 16. What is angle SRT? What's true about this angle right here and this angle right here? Come on now. So now what? How do you solve it from there? If this is 50, yes, and then, well, 65. I'm okay with that. 65 degrees. Everybody okay with that? If the vertex is 50, 180 minus 50 is 130. 130 divided by 2 is 65. Everybody good with that? All right. What's the length of TR? What does that have to be? 4. And CB must be what? The length of CB must be what? 3. Thank you. All right. Is everybody kind of feeling good about that? All right, keep going. 19, 20. You guys can do those on your own. All right, I do want to go down though. There's a couple down here that I want to double check with you. All right, this is something that's a good review for those of you guys who are going to take some standardized tests coming up. All right, everybody's got to look up. On 38, what's true? Tell me, Sebastian. Yes, x squared plus 5x equals 24. And because this is a quadratic, all quadratics have to be set equal to what? 0. So x squared plus 5x minus 24 equals 0. Now, I want everybody to see if they remember how to factor. Everybody see if you remember how to factor. All right, we said 2 sets of parentheses equal to 0. Come on, everybody's trying. I know it's been a while. What do you think?
X plus 8, parentheses x plus 8, parentheses x minus 3.
You are amazing, kiddo. So now x equals what?
-3.
Yes, x equals -8 or x equals 3. All right, now, usually negatives don't work. Does this -8 work?
No.
Well, if I plug it in, what's -8 squared? 64. 64 minus 40 is still what? 24. Does everybody agreeing with me? So the -8, in fact, what? Does work. And the 3, 9 plus 15 is 24. Does everybody agree that works also? Everybody's good on that? All right, so since we reviewed that, then everybody, I need everybody to do 39 on your own. That's another quadratic, just set it equal to factoring, those kinds of things. Everybody's good with this? All right, now let's look at see if there's anything I can help you with as far as these proofs go. All right, let's knock out 23, guys. All right, now, what I would like to do is, because triangle HJM is isosceles, immediately when they tell me isosceles, I try to also do the angles. All right, so do that for me. This angle is equal to this angle. Does everybody agree with that? Then it's also saying HKL is equilateral. Now, because it's equilateral, I'm gonna go ahead and mark 2, 2, and 2. So they agreeing with this. And then I'm gonna come over here and mark, well, this angle right here is equal to this angle right here, which is equal to this angle right there. Is everybody okay with that? JKH and HKL are supplementary. HLK and M. So they're just basically telling, I would just kind of understand that to be a line. Does everybody agree with me on that? That's what they're trying to tell you, that those are lines right there. Everybody okay with that? And I am trying to prove that JHK, I'm trying to prove this right here is equal to MHL. All right. Okay, so how can I do that? Well, let's start with this. Now, I don't mean how can I do that? What I basically mean is, in order to prove that, I need to show what's true, Sebastian. Thank you very much, guys. Is everybody okay with this? I'm trying to prove the left triangle and the right triangle are congruent. Does everybody agree with that? All right. And if I can prove that, then those parts are congruent. So we could say CPCTC, right? Everybody's good? So now we have to get into proving those triangles are congruent. Now, right now, does everybody agree I have angle side side? Does everybody agree I have angle side side? Is that a way to prove triangles are congruent? No, so that's not working.
Did you say hypotenuse leg?
You could say hypotenuse leg, very good, if they were right triangles. But it doesn't say they're right triangles. Everybody agree with this? Anybody have any issue with that? All right. So I need to somehow either prove JK is congruent to LM or angle HKJ is congruent to HLM. Does everybody agree with that? All right, so let's just write out what we know so far. Do I really care about the supplementary stuff? I don't really care about that. I think they should have left that out. All right. So what we can do is we can say this. Copy and paste that right over here. And notice I'm taking my white out here. I don't care about this piece. So this is step number one. Step number one. Now remember, guys, participate, please. Don't sit there. All right, so what else can I say is true? Now there's markings on the figure. So because there's markings on the figure, you have to now mark them. All right, you have to tell me why they're marked congruent. So I'm waiting. Go.
So it would be JH is congruent to HM.
JH is definitely congruent to HM, and that's what? Definition of what? No, nowhere to say bisect anywhere. Tell him.
Is it because it's an isosceles?
Yeah, definition of isosceles. It's isosceles if two sides are congruent, correct? All right, so now what else? Go. Okay, so we're going to say angle HJ, what? M or K? Either one, right? Angle HJK is congruent to, yes, HML. Why is that? That's right. Base angles of isosceles triangle are congruent. Or you can just say isosceles triangle theorem. It's up to you. Base angles of an isosceles triangle are congruent. Okay. So now I'm gonna leave the yellow. All right, I need some help here, guys. Step 4. Does everybody agree there's really no way to say JK is congruent to LM? Everybody okay with that? I don't see how I can do that. But what can I say? Go ahead, Walt.
Well, if you use the supplementary and.
Yeah. But why?
Because, like, supplementary and is.
That is 100% correct. So, but before you say that, then you'd have to say, Walt, Walt?
HL is supplementary to.
Yeah, you don't, yeah, so JKH and HKL are supplementary. No, I don't like that. No, let's say what's, tell me what your reason was behind that.
It's like, HKL and HOK.
Yeah, that's what you need to say. That's what you need to say first, right? So we need to say, that's what I was hoping you would say. We need to say that angle HKL is congruent to angle HLK. And we would say definition of what? Equilateral. Right. If you have an equilateral triangle, all sides are equal and all angles are equal. All right, now you can say what, Walt?
HO is supplementary to H.
Well, we already. Yeah, actually. Yeah, I should write that. Yeah, that should go in the given now. Because it's telling you that. I didn't even think to include that. I didn't think I was going to use it. All right. So, and you're going to have to write that angle JKH and HKL are supplementary. And the other two angles are supplementary, which is part of the given. All right, so extend the given. Now, I'm sorry, Walt, say that again now. Angle what?
Angle HLM is supplementary to HK.
Yeah, that's given though, right? HKL and JKH. These two are supplementary, right? And these two are supplementary. Isn't that what you're
Yeah,
talking?
I'm saying HLM is supplementary to HK.
No, I don't want to say that. I want to say, right? I want to say supplements of congruent angles are congruent. You see what I'm saying? All right, so I that's what I was trying to get. I wasn't understanding, but if you can, I'll listen to you. But does everybody understand what I'm saying? Right. So we know that HKL is congruent to HLK. Does everybody agree with that? So now we can say that angle. We can say that angle HKL is congruent to angle HLM. Angle HKL, come on guys, angle HKL is congruent to HLM. And that's supplements of congruent angles are what? HLM is congruent to yes, thank you, HKJ, sorry. Thank you very much. HKJ. Dang it. Does everybody see that? HKJ, sorry. HKJ and HLM are congruent because supplements of congruent angles are congruent. Everybody's good now? Now, from there, can we say the triangles are now congruent? By what? Side angle, angle, or I say angle, angle side, either way. But let's say triangle J, K, H is congruent to triangle M, L, H. And now once we say that, we now can say that. And somebody tell me why that's true? Yes. Anybody have any issues with that? Besides me stumbling through a couple of these. Sorry about that. Everybody needs to look up now and make sure you're understanding that. I think that's kind of tricky. Oh, gee, Merry Christmas. You're expert at that. Yeah. You're right. Two angles are equal. Third angle must be equal. Third angle theorem. It's even better. You could use the third angle theorem. Anybody have any questions with the third angle theorem? Say it.
So how do you know that it's more than both sides?
Angle, angle, side. The side is not between the two angles. You see that or not? Okay. This, like I said, sometimes it's not easy to see. So. Anybody else? All right, much appreciated. All right, let's look at the next one. All right, let's try something a little bit harder. Maybe. All right, let's mark the figure XY. Oh boy, how do I mark XY? Here's how you do that. You go like that. Your eyes can visually see it. XZ. See what I'm saying? When W and Q are in the way, it's kind of hard to mark it. Does everybody agree with that? So if W is the midpoint of XY, if W is the midpoint of XY, what is true? Say it again. I like it. XW is congruent to XY or WY. And Q is the midpoint of XZ. So what's true? So can I say that XQ is equal to WX now? Can I say all four of those are congruent? Anybody?
Yes.
We could say that's true, correct? Now, of course, it's going to be annoying to write all that out, but that's definitely true. Does everybody see?
So how would they all be congruent?
Well, the midpoint of, let's say this is 10. Watch this. This is how I, uh-oh. Yeah, something's happened. All right, hopefully it's working now. Oh. See if it works now. All right, we're back. Okay, so what I was trying to say is, look, let's say that length right there is 10. I'm gonna duplicate it. They're exactly the same. Let's say I find this midpoint. So that makes this equal to this, right? If I find this point, midpoint, this is equal to this, right?
Yeah.
So if I cut the same length in half, then all four sides are equal.
Yeah.
Right?
Mhm.
So all four sides of those are equal. Of course, I'm gonna have to demonstrate, but I'm just saying that's definitely true. All right. So prove that WZ. Prove this is equal to this. All right. Now, I haven't really done this, so this is a good opportunity for me to do this now. All right. So what I'm going to do right now is I'm going to take this triangle right here. And I'm going to pull it out to the side. This is W, this is Y, and this is Z. And now over here, I have what? Come on now. This triangle on the right. And this is Y, Z, Q. All right, so does everybody agree that QZ is congruent to WY? Everybody agree with that? Because we just talked about that, right? All right, so what else is true?
Or YZ compared to YZ?
Yeah, YZ is congruent to itself. What else is true? Come on now, I need somebody with good eyes to be able to see this one. What else is true? Come on, I just have one person. Someone else, someone else, someone else. All right, Katie, tell me why. Is congruent to, you're amazing. Right, these two angles are equal. Why are those two angles equal? Yeah, base angles of an isosceles triangle are congruent. You see how kind of tricky that is, guys? Come on now, you got to see it for yourself. All right, you got to see it for yourself. Now, what I'm talking about is this, guys. That's why this is hard. Does everybody see how we said this was equal to this, right? So automatically you should have said this angle is equal to this angle. Does everybody see that now? And that angle is this angle right here is equal to this angle right there. Everybody's good with that? All right. Anybody have any issues before I start this proof that's kind of annoying? All right. Proving WY is congruent to XZ is kind of annoying. All right. So let's get started on that. All right. The first thing I'm going to do is go ahead and just put this in here. And then I'm just going to white out that given part. Then I'm going to come over here. Put the given. Really, is that us? All right. So do me a favor. Do your best to fill in this proof. I'll give you a hint. Segment addition postulate. You're going to have to use the segment addition postulate for that. All right. I think we only have one other proof left. 1.5. All right. Try to get it done, guys. Please work on it. Remember what I told you. You're not going to be successful just filling it in when I'm speaking. Try. All right. Good job today.